Hi guys, welcome to Basic Bit. Today is December 15th and we're going to work on squares of a sorted array. Given an array of integers that are sorted in a non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. For example, we have this array nums. As you go left to right in the array, the numbers only get bigger. The most intuitive solution would be to first square every single value in the array. So -4 squared would be 16, and then 1, 0, 9, and 100. And once we do that, we can sort the array of squares to get the final output. Let's code up the straightforward solution that we discussed. So first, we want to get the squares of all the values in the array nums. So we can do a list comprehension. So we're gonna square every value for n in nums. So now squares contains an array with all the squared values. And then we just have to return the sorted array. So that's going to work. Let's look a little bit at the running time. To get the square value of every single element in the array, we're going to have to go through the entire array. So that's O of n. A good sorting algorithm will have running time of O of n log n. So the overall running time is going to be O of n log n. Now, if we want to improve the big O of our solution, we're going to have to come up with a solution where we won't need to use a sorting algorithm. We want to add the squares of all the values of nums to an array in a particular order. So one observation that we can make is that all the squares of this array nums is equivalent to the squares of their absolute values. So taking the square of this array would be the equivalent of taking the square of this array. And so the start of the array and the end of the array are going to contain the largest values. And as we move towards the center of the array, the values are going to decrease. So at each step, we can compare the value at index I and the value at index j and see which one of their squares are larger. So 100 is larger than 16, so we can add 100 to the answer array. And we move the index j over to point at 3. Now we compare 16 with 9. 16 is larger. So we add 16 and we increment I by 1. 1 versus 9, 9 is larger. So we add 9 and decrement j by 1. 1 versus 0, we add 1 and increment I by 1. Now I and j are both pointed at 0, so we just add 0. Now we have an array that's sorted in decreasing order. So for the final step, we just have to reverse this array to get it in non-decreasing order. 0, 1, 9, 16, 100. We initialize an empty array to store the answer. We're going to create a pointer I and j. I is going to point to the first value in nums, and j is going to point to the last value in nums. So we're going to increment I and decrement j in a loop. So as long as I is less than or equal to j, we're going to continue. We can store the values at index I and j into two variables called left and right. And we're going to store the absolute value of that integer. We're going to compare left and right, and whichever one is larger, we're going to add the square of that value to the answer array. So if left is greater than right, we append the square of left, and we can increment I by 1. Otherwise, we're going to append the right value squared and decrement the j index by 1. And recall, after the end of this loop, answer is going to contain all of the values in decreasing order, and we want it to be in increasing order, so we can return the reverse of the array. Submit our answer, and it was accepted.